Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast to help you understand the chemistry of your everyday life. Bonus edition.
Reunion edition.
Yeah, reunion.
Because we haven't seen each other for a month.
Mm-hmm.
It was supposed to be we took 2 weeks off because there was a holiday and then I was at a conference. And then at the conference, I think that there's a new wave of COVID because I've heard of so many people getting COVID, including many people at the conference I was at.
Yep.
So then we, just to be safe, we took another week off, and now it's been literally 1 month since we've interacted really in any way.
Yeah.
Except for very briefly, like
Online
at church
or
yesterday or at online.
Yeah, exactly. Also, maybe y'all didn't realize it, but maybe COVID had planned a conference also. It's like, hey guys, let's all get back together, all these different strains of COVID, different parts of the country. Let's get back together. It's been a while.
Yeah.
And maybe they scheduled it at the same time and it was like,
Probably so. But I was one of the only people in my group who didn't come down with it. So hopefully my bout of COVID Canada COVID last year saved me.
You won this time around. Lost that one time, but won this time.
Yeah, exactly.
If you've not tuned into one of our Q&Rs before, it's pretty awesome. One, we get so many good questions all the time from people who have either question based on an episode we did that kind of goes deeper or something we haven't heard or thought about before. And some of those turn into episodes, full-on episodes. Others are like things that Melissa can answer right here, right now. And we just kind of pool them together. And then once a month, we do it and talk about them.
Yeah. And we also like to wrap it up with some listener shout outs for people who've left reviews or sent emails and shared how the podcast has impacted them positively or any feedback that they may have, because we think that's really important to say thank you to those listeners who take the time to write those emails. So
this can kind of appeal to you too, is if you're someone who's like, wants some rapid fire kind of speedy, like, I want a chemistry question asked and I want a quick answer instead of like a longer drawn out thing. So a little change of pace. If that's your thing, cool, welcome. And if not, we'll see you in the other episodes.
That's right.
All right. Are you ready for the first question?
Ready. And a lot of these, I do want to say, are questions that people asked before our YouTube live, and we didn't get a chance to answer them because there were so many people. It was so interactive. So that's where those are coming from.
Right. Okay. First one is from Nelly on Patreon, one of our patrons. How did you know that chemistry was the thing you wanted to do?
So Nelly asked this in a coffee hour, and then we thought it would translate well into our YouTube live. But, I had this really amazing high school chemistry teacher. And when you talk to a lot of chemists, that's what they say. But at first I wasn't in her class. I was in the class next door. I had French, and my friend was in her chemistry class. And he would always come out with these really cool things, like they had a test tube that they turned the inside of it silver, or they had a penny and they hollowed out the zinc interior. So it was like a copper shell of a penny.
Right.
And one time they told me that, they held bubbles that they lit on fire in their hands. And I was like, I have to take this class. And I really, really loved it. I mean, it was just like, I loved the experiments. I loved the demos. I loved seeing how we could understand atoms and use them to change like what we're actually interacting with. And so I think that was it. I did have a brief period where I thought I wanted to do neuroscience, but then I realized I was just more interested in the chemicals than the rest of it. So I was like, this isn't for me.
Yeah.
But I think I got really lucky, and a lot of people don't know what they want to do. And if you're at that stage, I think that's okay. And keep doing fun things that you like and see where it leads you.
Yeah. That's cool.
Yeah.
Very cool. And if you were wanting my answer to the question, I don't do chemistry other than this podcast. And I guess you could say the short answer is that I wanted to help with the thing that Melissa wanted to do. And I like science too. And so I like learning it. We have like a mixture of listeners, some who are like currently studying chemistry or another science in school. Like they're like getting, one of the degrees that they're getting in that.
Yeah.
We also have people that are like me who just are interested in science and chemistry, especially when it's like brought into the everyday.
Yeah.
And so that made it really easy for me to be like, I'll help with this and I'm not going to have to pretend to be interested. So anyway,
Because you are interested.
Because I am interested. Exactly.
Not because you don't have to pretend because it's outright boring.
I don't have to pretend. It's like I just leave it there. I don't have to pretend. Anyway, that's a good question. This next one, oh, nice. Okay.
This is a really good one.
It's from Kristina, also one of our patrons. Why do you need to add extra grounds when brewing cold brew coffee versus hot coffee?
Okay, so I think I'm going to give my chemistry answer to this, and I feel like you might have a coffee answer to this.
Yep,
Is that true? Okay.
I do.
So from the chemistry perspective, hot liquids typically are better at dissolving things in them because they have more energy, they interact with more of the particles. And so, and a lot of times things being dissolved is literally like water molecules surrounding one individual atom or molecule of that other thing. So if they're hot, the molecules are moving around more. You know, if it's hotter, it's got more energy. They're able to more rapidly do that. And it literally just gets more out of the coffee faster when it's hot. Versus when it's cold, you're not going to be able to do that. And so there's something that's called it's like the liquid would be saturated. It's dissolved everything it possibly can at that temperature.
Yeah.
And then if you heat that same liquid up, it can take in more. So you've probably seen this if you've ever made like rock candy where there's a certain amount of, or just I guess dissolved sugar in anything. There's a certain amount of sugar that can go like in iced tea, but more can go in that same exact iced tea if it's warmer or if it's hot, even more. So you just are able to put more stuff into water when it's hot versus when it's cold, and it happens more quickly too. Mm-hmm. So that's my chemistry answer. Cold brew just doesn't have the same energy, so it takes longer, and you ultimately would get less coffee out of the same amount of coffee unless you put more grounds in.
Yeah.
What's your coffee answer?
Well, we've talked about some of this before. So like if I was to try to give my answer first, it would have definitely been affected by the podcast because we've talked about dissolving things. And we talked about coffee. I mean, we did several coffee episodes, so I can't say like a non-affected by the podcast answer, but a couple of things I would add. Oftentimes when you're doing cold brew specifically, a lot of places or a lot of recipes are trying to do a concentrate as well. So you literally want stronger coffee because one of the benefits is that you can store, say, like a mason jar's worth of concentrate. Mm-hmm. And then as you're diluting it every time you serve it, it's taking up less fridge space because it's a smaller thing, but it's just more concentrated. Tons of cold brew recipes are like that. And that's just a choice. Like you don't have to do that. And a lot of places don't. Like if you're at a coffee shop, there's a lot of benefits to doing that, and they'll dilute it every time they serve it so they don't have to store as much. But at home, you might not need to. So that's one reason that if you've just looked at a bunch of cold brew options and you've noticed it's like super strong, that's why.
Could be a concentrate.
Yeah.
And don't drink that straight.
Mm-hmm. Yeah. The other thing, all the stuff that Melissa was talking about is my understanding of it as well. And I've noticed that to be the case because it's not like exactly the same, like it's not, because you're brewing it at room temp or at cold. Some people brew it in the fridge, other people brew it at room temp. But either way, that difference of temperature, I've noticed that it's not like it's exactly, it's not like it's, even if I do a concentrate, it's not like it's exactly double every time or something like that.
Yeah.
I'm trying to think of a better word.
The proportion, maybe?
Yes. It's not like all things are equal and only the water temperature is changing. If I wanted to make and I have done this before, a non-concentrated version of cold brew, to have it taste good and taste like strong enough, I do have to have a higher ratio, more coffee to water than I normally would have. And another thing that I have experienced myself and heard is true is that cold things, our tongues are better at tasting things that are closer to our body temperature. Mm-hmm. And so hot coffee, when it's super hot, you can't taste it very well. But it gets down to about like, I don't know, 120, 130 degrees. We can taste that really well. And then you get things colder and colder. Mm-hmm. And that happens the opposite way where you can't taste it quite as well. So one thing that's true is I think just for it to taste right to us, you had exactly the same thing, one cold version, one hot version.
Our tongues taste it different.
Yep, taste it differently.
That makes sense.
For colder things, we have to increase their strength a bit to taste it, for it to taste similar. So, and
we did talk about that on our episode about why does coffee taste bad when you let it sit out. We did a whole episode on that and how our taste changes at different time or at different ranges of temperature.
Yeah.
That was a good answer, Jam. I liked that.
There's a couple of things I was like, these are like the coffee experience side that I had, and that there's definitely a science to it. But yeah. Sweet. Okay, ready for the next one?
Yes.
Brian M. asks this. Are my shoes chemistry?
I think he's asked this before, and I realized that I did him dirty a little bit because then we did the rubber episode.
Oh, yeah.
And I never even mentioned him, but we talked about shoes being made of rubber, and that's your shoes being chemistry. And so to answer your question, I won't do it here. You have to go listen to the rubber episode, but I let you down, Brian, by not giving you a shout out. So I'm bringing it back in this Q&R and saying I was wrong.
Yeah.
So thanks, Brian. And go listen to that rubber episode and then you'll know.
Yep. So basically we accidentally said, yes, they are. And here's an episode about rubber.
Oh, whoops.
Yeah. So if he wasn't quite sure if you thought shoes were chemistry or not, definitely you kind of told him that. We just need to give him credit
because the episode wouldn't exist if not.
Yep.
Dang it! I got myself.
This next one is from, I love this. This is someone on YouTube whose username is Master Yoda.
I like to think it's the Master Yoda.
Yeah, it could be. I mean, we don't have any reason to believe it's not. Right?
I know, and the subject matter could be relevant to Star Wars.
Yeah, exactly. However, if this is the real Master Yoda, maybe whenever he types, he doesn't quite do the switch around the sentence thing.
You're right, because this is a normal sentence.
It's a normally, the sentence is a normal structure. But the question is, why are crystals so rare?
Okay, this is an interesting question because there's not really a good answer to it because there's so many different types of crystals. And not all of them are rare. So we just talked about if you make sugar candy, the rock candy with a super saturated solution of water and sugar, it will form crystals. And salts form crystals naturally huge. You can look up, salt crystal caves, and there are huge structures of crystals made of salt. And even like quartz is technically salt, or not salt. Quartz is technically a crystal, you find those like when you're out in nature and you find those like really sparkly rocks, So crystals in and of themselves are not rare. When you think of what a crystal is in chemistry is having a structure that is a repeating unit, and it usually makes these nice sort of geometric shapes, and that's what we recognize as a crystal.
Right.
If you're talking about, like why are other specific crystals so rare, we have a whole episode on why gemstones have color. And I think that it could be that the specific arrangement of the atoms you have to have and the little anomalies that you have to have without giving too much away to make them have that color. Sometimes that occurs more rare in nature, but crystals themselves are not rare. So it's kind of like a question back is what crystals are you thinking of that are rare? And I have heard, although I don't know a ton about this, that, diamonds, for example, aren't that rare, but they put an artificial scarcity sort of on it to make them seem more rare and more valuable.
Right. There's a cap on how much they'll like sort of release into the market every year or something like that. Yeah.
So this is a good question. It's kind of a tricksy one.
Yeah. There probably are some that like might be super rare or for only some conditions, but then some you can make on your stove. So it's like kind of crazy that they're like that different from each other.
Yeah.
This is a cool message we got from someone named Rachel. They sent us this email. It's a bit long, but it's really cool. So let's read that real quick. Hi, Melissa and Jam. That's us. Hi.
Hey.
Hi, Rachel. My name is Rachel. I'm a huge fan of your podcast. I'm currently a graduate student studying chemistry, and your podcast has helped me maintain my broad understanding of chemistry, which is hard to maintain when I'm focusing on such niche projects, that makes sense. It's really helped me combat my imposter syndrome while learning cool facts and everyday applications of chemistry. My favorite part of the podcast is when Melissa discusses relevant research papers. Your podcast has also been really helpful for me in learning to become a better chemistry instructor, and all around, I'm a huge fan.
Okay, so I want to interject here real quick because Rachel mentioned feeling like an imposter, and we did a whole episode about feeling like an imposter in grad school. And grad school is really interesting as a scientist. You go in and you do get a more broad and deep understanding of chemistry than you probably did in undergrad. But then you go and do research in one specific area and you're thinking about that area all the time. And sometimes you can sort of lose the immediate memory of like, oh, yes, I learned this and it's this. And you've seen me even talk about that on the podcast. And so I'll be like, I should probably know that, but I just can't think of it right now.
Right.
But the thing is, you learn the fundamentals and you can apply them in so many different situations. And that's really what the broad knowledge in grad school that you hopefully gain is. But just because you're focused in, you can sort of feel like you don't know as much as you quote unquote should about other areas, or that you maybe they're going to find out that I don't know as much as I'm supposed to know. And then they're going to think I'm an imposter. And that is really something that we work on this podcast to combat. And that's why I'm so open about when I don't remember something or if I make a mistake. And so if you're in a similar position and you want to learn more about that from a licensed counselor, we did an interview with friend of the podcast, Vianette, who is a licensed counselor, and she shared a lot of really good information about feeling like an imposter in those spaces and how it's even more, the space itself is built in such a way that reinforces those feelings for some people. So it was really, really helpful. And I encourage Rachel and everyone to go back and listen to that if they haven't already.
Yeah, that's when we're doing those fall minis, or what do we call them?
Yeah, we did fall minis because I was about to go into my dissertation year and I was doing too much.
Well, it's cool because we got to do some topics and some episodes that are a little different than what we normally do, and that was one of them, and it was really cool.
So, it was really cool.
Here's some continued stuff from Rachel's email.
Back to the email,
Yes. While I was listening to the recent episode on what makes cars so hot, I got really excited because I think I know some of the answers to your questions. Forgive me if I mentioned something you guys already discussed on the podcast. One, the reason that water and CO2 get warmed up by infrared light is because the molecular vibrations that occur. I love animations of it, and she sent a video that shows the animation, which can't occur in O2 or N2 because of their double or triple bonds that aren't bendy.
Yes, so we did talk about that very briefly. As I was like, I'm not really going to touch on why they get warmed up by infrared light, but they do. And you can go and look at a really cool video. We have linked in our references on that episode from the American Chemical Society that goes into it really well and in depth in a way that it didn't feel like, oh, this podcast wasn't the space for it, but it could be really fun if you want more information. So shout out to Rachel for bringing that up.
Yeah. Continue her email. Number 2, generally, infrared light is the heating light because of this reason listed above. It just has enough energy to make molecules move faster, and that is why it was primarily discussed in Melissa's research for the episode. I also have the same question about why UV is discussed less in this application, and now I'm asking myself a bunch of questions and doubting everything I thought I knew. Typical day in the life of a graduate student. If a material scatters the UV light inelastically, the energy frequency of the light will reduce, and if you do that enough times or lose energy, you can end up with more infrared light. Also, if the material absorbs the UV light, it could lose or give off that energy as heat or emit a longer wavelength / lower frequency. This would happen instead of being used to break bonds to degrade materials like you talked about in the photo bleaching episode. So I suppose the UV light would play some contributing factor, but I think, emphasis on think, I'm not totally sure at this point, it would only do so in the sense that it could produce more infrared light.
Yes. So I think we can stop there with the email, but I wanted to shout that out because I agree with what Rachel said. And I think I had that same thought process when it occurred to me on the episode that I suddenly didn't know, you know? And when I was researching it and trying to figure it out, I think we came to a similar conclusion that it must contribute, but it must contribute in such a way that it's either negligible or it's essentially eventually getting to infrared, you know?
Yeah, right.
It's a small amount. It's an indirect effect of UV light. And Morgan on YouTube also came and said something similar. She said, I suspect a similar reason to what Melissa proposed. The reason UV energy isn't focused on as much as IR is because UV is ionizing radiation and IR isn't. UV is energetic enough to break bonds, but IR doesn't do that. It'll just heat things up more. I will say I also assumed that Morgan was a she, but Morgan is a gender neutral name. I know a boy Morgan, so whoops. Sorry, Morgan, if you're a boy. Morgan also said, I literally sang the song about heating a closed container. If you heat a closed container, it's a bomb.
Yeah.
That's a song that, who made that up?
Justin, we had talked about that from one of your teachers, but
yes,
Justin turned it into a song.
Yes.
And at least the way I read it when he sent that to us seemed exactly like that. If you're happy to know, clap your hands.
Yeah.
The at least the rhyming patterns like that matched it perfectly. So
they also commented that they sang the song about heating it in their lab safety class. So that was really fun.
That's awesome.
And also Morgan is our most prolific YouTube commenter. So thanks for all your comments, Morgan. They make us really happy.
Yes.
Okay, so I think that's kind of a good place to wrap up, but there are a few shout outs that I wanted to give. So I'll give the first one and you can give the next one if you want.
Sure.
So first we got an email from someone named Kathleen who said that I just want to shout out and a thank you for your podcast. I work with a 23-year-old girl with autism named Caitlin who loves chemistry. She chooses to listen to the podcast in the car instead of music, which I also listen to podcasts in the car instead of music. So I think that's sweet. She chooses to listen to the podcast in the car instead of music. She's studying to get a high school diploma and they did not prepare her in school. She's brilliant and has just been able to spell with us in the past 2 years to communicate. So that's really exciting that someone who wasn't prepared appropriately and doesn't have other ways to communicate clearly is able to use this and get a lot out of it. I was like, these are our science communication dreams. They're happening.
That's awesome. Dang.
So thank you for that email, Kathleen.
Here's another little shout out from Joseph B. I love the podcast. I'm an undergrad biochem major at Furman University, and I love the approaches Melissa takes to teach people of all the chemistry backgrounds and why things happen.
Yay. Thanks, Joseph. That's exciting.
Do you read the next one?
Yes. The last one is from a YouTube comment from Idris A. And he said that he was commenting all the way from Oman. And I love hearing from listeners where they're located. I think that's really fun. It kind of makes it feel a little bit more real. Like you're not just a name on the screen that could be my neighbor. You're from Oman. And so hearing, we have friends that are from Spain, from the Basque Country, from, Brazil, from Australia. I think that's really fun. And we can see it on our analytics, but it's fun for it to be a person,
Yeah, it is a little hard to believe when we look at the analytics and see how many people are downloading in different countries. It's like, okay, I see this, but do I believe it? I mean, it's a little hard, but
it could be an anomaly. It could be ChatGPT doing something suspicious.
Right. But then we hear from someone who's from somewhere else, and then it's like, okay, yeah. Real human beings in real other places. This is the best. That's so cool. So exciting. Yeah. Thank y'all for those shout outs. And we're grateful for y'all's encouragement. And it means the world to us. So keep those coming. Melissa and I have a lot of ideas of topics of chemistry in everyday life. We want to hear from you guys, your questions, just like the ones we've been talking about in this episode. We love hearing those. Yeah, so please reach out to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to patreon.com/chemforyourlife or tap the link in our show notes or the description to join our super cool community of patrons. If you're not able to do that, you can still help us by subscribing on your favorite podcast app, subscribing on YouTube, and rating and writing a review on Apple Podcasts, because that also helps us to share chemistry with even more people. Yeah, and that really does help. If you get anything out of these episodes and you're willing to leave a review or to tell someone else about it, that is the best way that our podcast can get out to other people who want to learn about chemistry. Mm-hmm. So I also want to say that people who are responsible for helping this podcast continue are our financial supporters over on Patreon. It means so much to us that you want to help make chemistry accessible to even more people and that you support us financially. Those supporters are Avishai B, Bri M, Brian K, Chris and Claire S, Chelsea B, Derek L, Emerson W, Hunter R, Jacob T, Kristina G, who we heard a question from today, Lynn S, Melissa P, Nichole C, Nelly S, who we also heard a question from today, Stephen B, Shadow, Suzanne P, Timothy P, and Venus R. Thank you again for everything you do to make chemistry for your life happen. Yay, chemistry! Yay, chemistry!